Okay, let's conclude this chapter on climate and vector-borne and zoonotic diseases by looking at some non-mosquito vector-borne or zoonotic diseases. Lyme disease is zoonotic, the tick that is being carried by various hosts are coming into contact with humans, and it's gotten a lot of attention because in the US there's been an indication of increase over time in the incidence of Lyme disease. So this is cases per 100,000 people, going from the 1990s into the most recent period, 2019 or so. And you can see that there is definitely an uptick here. Not clear if it's flattening out, but again, the complication is to look at how this disease gets transmitted and how those parameters are going to be affected by climate and weather. Lyme disease symptoms include early signs in 3 to 30 days after the bite. So this also can go without any symptoms for a while. It's spread by a tick here. So you can have fever, headache, fatigue, bullseye where the bite happens, which is a clear indication that you got bit, and it's definitely something you should check if you are been hiking in the woods and come back, or even walking in a park and so on, and look for ticks and tick bites, and irregular heartbeat. So early signs include these, and later signs include irregular heartbeat, dizziness, and the bullseye. So you can see that bullseye may appear much later than these other symptoms, and it can remain in a body for a very long time. In 2012, Lyme disease was the 7th most commonly reported infectious disease and most frequently reported vector-borne disease in the United States. Drivers of Lyme borreliosis are multifactorial. They include climate and non-climatic factors, reforestation, overabundant deer, increased tick population, suburban encroachment on wooded areas, and increased human exposure to ticks, as well as temperature and precipitation. So again, this is a complex combination of factors, so we have to remember our convergence model that we looked at the first podcast in this chapter. So figuring out climate impact is going to be quite complicated in that sense. But this idea of suburban encroachment is one thing, but there are also the other way things are happening, where a developer wants to develop new housing group of houses, let's say, and he wants to have wooded areas as part of the attraction to the neighborhood. But many people are now worried that wooded areas will bring deer, who have no predators anymore in the US, and the deer will bring Lyme disease. So they don't want wooded area, which would be nice to have, because they're afraid of Lyme disease. So you can have human behavior affecting these things in a very strange way. This is a map from Trail Running magazine, which shows regions of across the world, in case you are running wherever you go for work or travel. Regions which are non-endemic, regions that have sporadic Lyme disease, and regions that are endemic to Lyme disease. So in that sense, the US is endemic, but it's got increased incidences because of various factors like suburban encroachment and people just being more outside and so on. Okay, deer tick is the main carrier of Lyme disease. Rabies in wild carnivores and bats. Rabies prevention can be, so I'm just jumping to a statement from the book. Rabies prevention can be highly effective by promoting the removal of stray dogs, providing vaccination to domestic dogs, and avoiding contact with the animals that may be dangerous. So rabies affects all sorts of animals. So the Lissa virus hosts animals found around the world, Arctic fox up in high latitudes, raccoons, dog, fox, bats, skunks, coyotes, insectivore bats, dogs, vampire bats. Bats are usually frugivores or insectivores, but Vampire bats are the ones that feed on bloods of mammals, and they are obviously got a bad reputation as well, scary reputation as well. But you get the idea that there are multiple hosts for the lyssavirus, which is spread through the saliva. So the bite then becomes very important. So how is it spread? Here we have mongoose to raccoon dog to humans. So you let the dog run around, it comes in contact with these other carriers, hosts, and then comes back to you. Or it can circle between bats, which can directly be exposed to, or humans can be directly exposed to vampire bats in some cases. They do occasionally bite humans, foxes, and then dogs, right? What are the symptoms of rabies? Once symptoms of the disease appear, rabies is almost always fatal to both animals and humans. Diagnosis of rabies on clinical grounds alone is difficult and often unreliable, so it's a very difficult disease to diagnose. But now vaccinating the dogs is important, and as soon as you get a dog bite, obviously people have to rush to the doctor and get all those shots. I think you need something like 10 or 12 shots to prevent rabies, even if you don't know whether the dog actually has rabies or not. In animals, the most reliable signs of rabies are acute behavioral changes and unexplained progressive paralysis. Animals may show signs of agitated aggressive behavior and lethargy and paralysis. So when animals begin, especially stray dogs or your own dog, begins to get aggressive and so on, it may be affected by lyssavirus. In humans, the first signs of rabies may include headache, fever, anxiety, and tingling, or altered sensation near the site of the animal bite, if you have been bitten. In most human cases, it's also characterized by dilation of pupils, unusual sensitivity to sound and light, and changes in temperature, as well as seizures, hallucinations, and hydrophobia. Hydrophobia, this is a key factor as well. That is, spasms on touching or even seeing water. How amazing is that? A virus can make you scared by just seeing water. In both humans and animals, rabies progresses from paralysis to coma and then eventually death. Okay, so here is a vampire bat, which is mostly present in these regions here of South Central America into southern US, where it lives, and it is something that feeds on animals and occasionally humans, and it carries lyssavirus and can cause rabies. Finally, average temperature so look at some of the complex pathways through which rabies disease outcome can be affected. Average temperature increase, decreased and unstabilized sea ice. This is for Arctic foxes. So climate effect on human exposure to rabies from Arctic fox. Increased geographical limitation between inland and coast, leading to lower human rabies exposure from Arctic foxes, or limited access to marine food resources, reduced seal carcasses from polar bears, ringed seal habitat, and Arctic nesting birds, decreased population density of Arctic fox, leading to lower human rabies exposure from Arctic foxes. Obviously, foxes, this is not good news. We are not trying to reduce the population of Arctic foxes so we can be less susceptible, less vulnerable to rabies from Arctic foxes. But these are the unintended consequences of anthropogenic activities and fossil fuel emissions and impacts on temperature, leading to sea ice changes, leading to habitats changes, ecologies, animals, populations, and so on and so forth. Okay, so this is a quick run through some of the zoonotic and vector-borne diseases. As we saw in the beginning, there is a much longer list as well. All of them depend on the climatic parameters that we talked about directly or indirectly, as we saw, mainly temperature, precipitation, relative humidity, and winds. And then there are always vectors and animal contacts that are involved. So we have to understand the entire cycle to understand the climatic impacts on vector-borne and zoonotic diseases, or VBZDs. Okay, we'll end this chapter here and come to the next chapter in the next podcast. Okay, see you there.